just before collision, it is having velocity u like this. Then we know any impulse will act here. And the impulse on this will act here. So look at the question now. Length of the string, 1.5 meter. This there. Collides elastic. If the suspended ball just complete vertical circle after collision, calculate the velocity of the falling ball just after collision. It is asking to calculate this u. So that after collision, this will complete vertical circle. After collision, what happened to ball A? How do it move? What are the impulses? Impulse due to string also will come. No? So here impulsive JT will now what should happen to this one here? Already I think I discussed the problem, just it's a very simple idea. And now in what action you can conserve momentum? Along line of impact. There's a line of impact. Along x, along line of impact, or along y-axis. Only along x-axis, because component of impulse due to tension the string will be set up, and because of that you see plus j minus j. What about this jt will be unbalanced? So line of impact I cannot conserve momentum. Along y-axis, component of j, this j and this j will be acting, but this will be unbalanced, so momentum is not conserved along y-axis. What about along x-axis? Yes, component of this j and this j will be equal and opposite. Component of jt along x-axis will be 0, so momentum is conserved only along x-axis here. Okay, let's see that. Now it should complete vertical circle. So just after collision, what should be the velocity of this ball should be? So this velocity of ball should be in this direction, so that it will complete vertical circle. Then what about the ball, other ball? The other ball, how do it will move? An impulse will act, component of impulse will act vertically, other component impulse will be acting here. So let's show the other ball, the situation of other ball. Rough diagram. Oh. Yeah. So this will be the thing, that one. So other ball will have some velocity, say VBY, VBX. Applying conservation of linear momentum. So what is VA? We know, we are very sure, no? What should be VA? VA should be equal to root of IGL. We know length of the rope. So this will be 1.5. Root 75 meter per second, or 5 root 3. Okay, clear this. Then after getting VA, can we calculate VBX? Momentum must be conserved. Initial momentum along x-axis 0. So final momentum should be let's go write it here. Initial momentum 0. Final momentum should be MA VA minus MB VBX. Since MA equal to MB, so therefore VA equal to VBX. So I got the X component of velocity of this one. So therefore what is the VBX should be equal to? VBX should be equal to 5 root 3 meter per second. So I know VBX. You know, component of impulse only will produce that particular velocity, no? So here you resolve. So what is the, I think, collision. So when it occurs, I think we need this theta. If I know this theta, so J sin theta only will impart that. J sin theta should be equal to MB VBX. From this, I know theta. Theta should be, I think, 2R by R. Theta should be 30 degrees. Am I right?
Yes, sir.
Theta is 30 degrees. So J by 2 M 5 root 3. So J is equal to 10 root 3 M. Now, if I know this impulse, can I calculate now other thing, that one? I don't know VBY. How to calculate VBY? Applying quotient of restitution along line of impact. This is after collision. This is before collision. Then applying quotient of restitution formula. This is theta. This is theta. I want theta, no? This is theta. This will be theta. Yeah. Okay, let's write quotient of restitution formula. Collides elastically. So 1 is equal to, or let me write, E is equal to VA sine theta minus, I need some little bit space, more space I need it. I'll slide down. I'll write, looking at these two diagrams, quotient of restitution formula. E is equal to VA sine theta, this will be positive, minus VBY cos theta, positive, minus of, this will be VBX sine theta. Now two components I'm bringing. How it is possible? And this should be U cos theta. This is initially a test, no? Try to see this. Why two components have come here? Look at this part of the thing. After collision, velocity of ball B, VBY cos theta will be there along line of impact, and other component VBX sin theta, and now VBX sin theta in that direction. So I'm putting both the components here. So we know what all we know: VBX, we know VA, we know VBX and VA, and we know U. We know E equal to 1. Solving will get VBY. After getting VBY, then what I do is I'll apply the impulse concept. So what is the impulse? Mu minus J cos theta should be equal to M VBY. Problem really is it's twisting lot of things here, that one.
Sir,
Then
is
we
E equal to 1?
E equal to 1, it's given, no? Equal to 1. So now we know J, we know theta, we know VBY. Substituting this, we'll get the value of U. No. That is, it's in contact. What happened? That impulse JT is acting only on the ball A, will not have any impact on the ball B. That impulse JT will not have any impact on it. So JT acts only on ball
Sir,
A.
U should be equal to VB, no sir. VBY.
Impulse is acting, no, J cos theta. J cos theta will be there, no? Because of J cos theta, things will change. Okay. This is after collision, this is before collision. VBY you may get negative also. That you have to check it from the calculations. Now the answer I given, cross check afterwards. So now see like, is there any loss in E equal to 1 is telling. So no loss in kinetic energy, that one. So this will come and collide and it will impart the momentum. Collision occurs, but impulse is set up in the string, no? Because of the impulse setup, jerk is produced. So there should be some energy. How to justify? On one side, E equal to 1 is there and a jerk is produced here. How to justify this? A jerk is produced here, no? And it's an elastic collision. See, the collision between them occurs elastically. There'll be exchange of velocities since masses are same. So there'll be exchange of velocities will occur. All that particular thing. So now what happened? Here, sir, can't we use exchange of velocity along line of impact? Why I didn't think like this? Anybody? Why didn't we go for any exchange of velocities along line of impact?
That JT component is acting.
The value